This is Half Past Paper Week 15, Higher Tier, and these are all the topics that we're going to be doing today, starting with prime factor decomposition, really common first topic on these papers. So here we go. Question number 1, write 84 as the product of its prime factors. So 84, we're going to start with that at the top, and we need to think of two numbers that multiply together to make 84. Now you've got lots of options here. You could go for 12 and 7, you could go for 42 and 2. It doesn't matter what you use, okay? As long as if you get to a prime number, you're going to circle it, and that kind of stops that section and carry on with the other side. So 12 is 2 times 6, 2 is prime, so let's circle that. 6 is 2 times 3, and they're both prime, so they both get circled, and we are done. Therefore, our answer is 2 times 2 times 3 times 7. Now that's actually all we need to write for both marks there. It didn't say give your answer in index form. If it did, you would have to write it as 2 squared times 3 times 7 with that indice for the 2 times 2, but either of those answers was absolutely fine for 2 marks there. I'm just going to write 2 times 2 times 3 times 7. You have to put it with multiplications in between. Most common mistake I see is with commas in between. That's going to lose your mark, okay? So with multiplication in between, so that when you times those numbers, it does indeed make 84. Find the lowest common multiple of 60 and 84. Okay, so we've just done the prime factorisation of 84. Now let's do the prime factorisation of 60. So 60 is 6 times 10. Neither of those numbers are prime, so let's go again. 2 times 3 makes 6, and 2 times 5 makes 10. There we go. And so 60 is 2 times 2 times 3 times 5. I'm now going to do a Venn diagram. This circle is going to be for 60, and this circle is going to be for 84. And we're now going to look at both this and fill in that Venn diagram. So they've both got a 2 that can go in the intersection. They've both got another 2, so that can go in the intersection as well. And they've both got a 3, so that can go in the intersection as well. I've got a 5 left over on the 60 that I haven't used, and I've got a 7 left over on the 84 that I haven't used. Now, if I'd asked you for the highest common factor, it would be all these numbers in the middle multiplied together. So the highest common factor, the biggest number that goes into both 60 and 84, would be 2 times 2 times 3, which is 4 times 3, so 12. So the highest common factor would be 12. If you want the lowest common multiple, you take that 12 and multiply it by any numbers left on the outside. So 12 times 5 times 7. So let's put that somewhere else, let's put that over here. Lowest common multiple is 12 times 5 times 7, any numbers left on the outside, which is 420. And you have got a calculator, so you can use your calculator for that one. This was a calculator paper. Fabulous, there we go. Next question. Question number 3. Carlo puts tins into small boxes and into large boxes. He puts 6 tins into each small box, and he puts 20 tins into each large box. Carlo puts a total of 3,000 tins into the boxes, so that the number of tins in small boxes to the number of tins in large boxes is in the ratio 2 to 3. Okay, so whenever I see ratio, I do find it helpful to do some little lines like this, so we know there are 5 parts altogether. We're sharing in the ratio 2 to 3, where this is small boxes and this is large boxes. Now we know that there are 3,000 tins. So those 3,000 tins need to be split in that ratio. So we're going to do 3,000 divided by 5, and that is 600. So that means I've got 600 on each of these little lines. Now that tells me that there are 1,200 tins going into small boxes, and there are 1,800, because that's 600 times 3, 1,800 tins going into large boxes. Okay, great. We know that 6 tins make up one whole small box. So I know that if I divide this by 6, that's going to be 200 small boxes. And then I know that making a large box is 20 tins. So let's divide this one by 20. So 1,800 divided by 20 is 90. So we know that there are 90 large boxes. Great. It then says that Carlo says that less than 30% of the boxes filled with tins are large boxes. Is Carlo correct? So we need to know, is 90 30% of the total number of boxes? So there's 290 boxes in total. 90 out of 290, to get that as a percentage, we just times it by 100. So if I type that in my calculator, 90 on the top, come down, 290 on the bottom, times by 100, that is 31.03%. That's one way of doing it. Another way of doing it would be to say, well, 10% of 290 would be 29. You could times that by 3. 29 times 3, or 30% of 290, was 87. So then we can say no, because it's 90, so that's more. So he's saying less than 30% of the boxes are large. So Carlo is incorrect, as more than 30% are large. And you could say that 90 is greater than 87, but with that would be enough, or seeing that and that would be enough. So lots of different ways you could have got 5 marks there, but there we go. That was it for 5 marks. Well done if you got that. Question number 5, work out the value of x. So this is a right-angled triangle, and we've got an angle involved. So that's telling me that this is a SOHCAHTOA question. I'm going to pop my triangles up here, SO, CA, and TOA. And first thing we're going to do is label our sides. I want you to go over from the right angle. That is your hypotenuse. So this is our hypotenuse. Then I want you to imagine you are stood in the angle that we are interested in. In this case, it's the 34-degree angle. And you're looking into the triangle. Which side is next to you and which side is opposite you? So this side over here, that's opposite. And this side next to you here, that's the adjacent. And the adjacent is normally found between the angle you're interested in and the right angle. So there we go. What two sides are involved? Well, I know the hypotenuse, so that's helpful information. So I want to make sure H is in my formula triangle. And I want to know the opposite. So that needs to be in my triangle as well. Which of the triangles has O and H in it? That's going to be SO. So we're going to be using SO for this question. Let's do it again, big down here. I didn't know the adjacent, it wasn't helpful information, and I also didn't want to know how long it was, so there we go, that's not involved. So now I want to know the opposite. You cover up the thing you want to know and do the sum that's left behind. Now remember that the S is sine 34. Had we have been using CA, then the C would have been cos 34. Had we have been using TOA, the T would have been tan 34. So there we go. Sine 34, and that's multiplying by the hypotenuse. So sine 34 times 178. I'm just going to type that in my calculator. And that is 99.53633. I always like to write what is on my calculator to a good few decimal places, and then I'll round it on the answer line. So it says to 1 decimal place, so that's going to be 99.5. Does that make sense? Well, yeah, it does. I don't need to put millimetres because it's x millimetres, so that's fine. The hypotenuse is 178, and that's the longest side, so I'm happy that that's a sensible answer. It's a shorter side, so there we go. Question number 7. The diagram shows a right-angled triangle and a quarter circle. The right-angled triangle ABC has an angle ABC is 90. The quarter circle has centre C and radius CB. Work out the area of the quarter circle. So to work out the area of a quarter of a circle, area of a circle is pi r squared. But then we know that if it's a quarter of a circle, we're going to need to take that answer and divide it by 4. You might also be happier with the idea of timesing it by 90 out of 360, and either of those are absolutely fine, okay? But either way, we need to know what the radius is. We need to know the radius of a circle. Now, the radius of a circle is that, but it's also that. So can we find out how long either of those lengths are? Yes, we can. We can use that right-angled triangle, and we can do Pythagoras. I know this is Pythagoras because I've got 2 sides, and I want to know the third side. So we're going to do 9 squared take away 6 squared. Now sometimes with Pythagoras we add, and that's if we want the hypotenuse, and sometimes we take away, and that's if we want a shorter side. So because 9 was the longest side, the hypotenuse, and we had that, we wanted to take away here. So 9 squared take away 6 squared is 81 take away 36, and then we're going to get that answer, and then we are going to square root it. Always with Pythagoras you want to square root at the end. So 81 take away 36, and the square root of that answer is 3 root 5, or you can write it as 6.708203932. Now I don't really want to round it at that point, and I am going to keep it in my calculator because I now want to do pi times that answer squared, so in my calculator I'm using my answer button, pi times that answer squared, because I don't want to round it, and then I'm going to press equals, and I get 45 pi, and then I want to make sure I divide that by 4 or times it by 90 over 360, because I don't want the whole circle, I don't want all of this, I just want a quarter of that circle. So let's take that answer, divide it by 4 or times it by 90 out of 360, and that is 35.34291735. They want it to 3 significant figures. So there's your first significant figure, there's your second, there's your third, 4 rounds down, so 35.3, and we are in meters squared here. That's fine, the units are on the answer line, so we're okay with that. 35.3 is your answer for 4 marks. Question number 9. Aisha recorded the heights in centimetres of some girls. She used her results to work out the information in this table. Aisha drew this box plot for the information in the table, and the box plot is not fully correct. Write down the 2 things Aisha should do to make the box plot fully correct. So the least height is 142. Now let's have a little look here. If I zoom in on this, I can see that 140 is here, 150 is here, and there are 10 little squares in between, so we are going up in ones, so I'm happy that that lowest height is at 142. This would be your lower quartile, this would be your median, this would be your upper quartile, and this would be the greatest height up here. So let's check all the others. We're happy that that one's okay. The lower quartile is at 154. Yep, I'm happy that that's in the right place. She's done that correctly. Now the interquartile range, that is the size between the upper quartile and the lower quartile. So I want to know the difference between that value and that value. Now this one is at 172, the upper quartile, and the lower quartile is at 154. That does not have a difference of 17. So if I do 154 and I add 17, that should be 171. So that's the first thing that's wrong. If the interquartile range is going to be 17, which it should be, then our upper quartile needed to be at 171. So upper quartile should be at 171 centimetres. That's the first thing she's done wrong. Okay, then we'll check the median. The median should be 162, and we can see she's plotted at 161. So median should be plotted at 162, not 161 centimetres. There we go. They've asked me what she should do to make the box plot fully correct. So we're assuming that these values are correct and these values are wrong. And you want to make sure you kind of notice that in your wording. Let's just check the last one just to be on the safe side. The range should be 40. Now the range is the difference between the highest value up here and the lowest value down here. And we can see that that is 182 and 142. So yeah, I'm happy that that one is correct. So your issue was with the interquartile range and the median. Question number 11. Jack is in a restaurant. There are 5 starters, 8 main courses and some desserts on the menu. Jack is going to choose 1 starter, 1 main course and 1 dessert. He says there are 240 ways that he can do that. Could Jack be correct? Well, when we think about combinations, we need to multiply. If I've got 2 t-shirts in my wardrobe and 3 pairs of jeans, 2 times 3, there are 6 different outfits that I can wear. So we're just multiplying here. There are 5 starters. There are 8 main courses and we don't know how many desserts there are. But Jack is saying that there are 240 different combinations. So 5 times 8 is 40. So he could be correct because there is a number that we can multiply 40 by to get 240. This is in the 40 times table, so that's okay. As long as there are 6 desserts. So 240 divided by 40 is 6, which is a whole number. If you've got a decimal value, 5.8 for example, then you'd know, no, he can't be correct. There can't be 5.8 desserts. But because it's an integer, a whole number, yeah, I'm happy with that. So I'm going to say yes, as long as there are 6 desserts. But as long as they see the value 6 and yes, then you're fine for both marks there. Question number 13. Now, this is giving me cosine rule or sine rule vibes. It's a triangle. It hasn't got a right angle, so we can't use theorem, we can't use Pythagoras. And we're being asked to work out the length of AB. So I'm going to pop a little X here so I know what it is I'm trying to work out. Now, if it is cosine, the setup for cosine would be that you would know, so let's say this is 10, this is 12, and this is, I don't know, 58 degrees, and you'd want to know that over there. So you'd have two sides, and you'd have the angle in between, and you'd want to know that side over there. That would be for the cosine rule. For sine, we work in pairs. So for sine rule, you need to know a side and the angle that is opposite it. Now, this is a little bit of a tricky one, because although I have this side, I don't have this angle that corresponds with it. And I need that in order to use the sine rule. It's not cosine because I don't have this set up, so that's no good. So I think it's sine rule. How could I get that angle? Well, it looks a bit difficult because they've not given you that angle, but they've given me the other two. So we can use the fact that we know that angles in a triangle add up to 180 to get this missing angle here. So let's get that first. So I'm going to do 34 add 26, which is 60. So those two make 60 degrees, which means 180, take away 60, I'm left with 120 degrees here. And I now have a pair. So I know that 23.8 and 120 degrees are a pair. And I then want to use 34, let's change colour here. I want to use 34 with the X. So I've got two different pairs. Your pairs are always opposite values. So the angle and the side opposite, the angle and the side opposite. Now, we want a side. So sides go on top. The sine rule can change. It can either be A over sine A equals B over sine B, or it can be sine A over A equals sine B over B. If you want angles, those are the angles with the capital letters, so we would use it that way up. But because here we want a side, we're going to do it this way up. Okay, so I'm going to put X over sine 34, that's my first pair, equals 23.8 over sine 120. How am I going to work out the value of X? Well, at the minute, X is just being divided by sine 34, so let's undo that. Let's times this side by sine 34, and let's also times this side by sine 34. So X is 23.8, and you can put your sine 34 on the top of the fraction if you want, or you can just leave it like that and times it by sine 34 afterwards. So I'm typing that in my calculator. I'm going to use the fraction button just to keep it nice and neat. 23.8 over sine 120, and we're timesing that by sine 34. Lovely. So that gives me 15.367. 668. They want it to one decimal place, so that's going to be 15.4, because that is your first decimal place and the 6 rounds up. So 15.4 centimetres for that one. Are we happy that that's a sensible answer? Well, yeah, I am. 120 degrees is quite a big angle, and that's opposite 23.8. I'd expect a smaller angle like 34 to be opposite a slightly smaller side, and that is 15.4 is smaller, so I'm happy that that's a sensible answer, and yeah, that is 3 marks. Question number 15, and we are asked to describe fully the single transformation that maps triangle A onto triangle B. So there are 4 transformations: rotation, reflection, enlargement, and translation. And you need to make sure you're only writing one of those words. If it says describe fully the single transformation, it's asking you to pick one. Now here we can see that the shape has got bigger. So this is going to be an enlargement. So I'm going to straight away write the word enlargement there. With an enlargement, we need a scale factor and we need a centre. So scale factor and a centre of enlargement. Firstly, let's have a look at the scale factor. And I'm going to draw some lines in here as well. So you might find this helpful to find the centre. We're going to match up the corresponding points. So that point corresponds to that point. This point over here corresponds to this point over here. And this point up here corresponds to this point down here. And you can see that they are meeting at this point here. So that is going to be my centre of enlargement. That is 1, 1. And the scale factor, well, we can see that this was 2 tall and this was 3 tall. So we're going from A to B. Good, yeah. So 3 divided by 2 is 1.5. But if it was an enlargement 1.5, it would have ended up 1.5 times bigger going in the same direction. Because it's going back through the centre and out the other side, you're kind of getting that twist back through. That is a negative enlargement. So I am going to put minus 1.5 as my scale factor there. Minus 1.5 or minus 3 over 2 would be absolutely fine as well. There we go, 2 marks for that one. Question number 17, write down the coordinates of the turning point on the graph of y equals x add 12 squared minus 7. Now this is completing the square, the topic, but they've actually already completed the square for you, so we're just looking at this. Now when you complete the square, we get it in this format. Y equals x add 12 all squared minus 7. Now to get the coordinate of the turning point, this is a quadratic, so it's coming down like this, going back up. The turning point is this value here. To get that, we need to say, well, what would make our bracket equal 0? What value of x would make that bracket equal 0? What number would we need to put here to make that bracket equal 0? X would need to be minus 12. So that's your x coordinate. And then the y coordinate is just whatever the constant is here, including that sign. So minus 7 is your y coordinate. Minus 12 minus 7 is the coordinate of that turning point. Very nice for 1 mark. Question number 19. A hot air balloon is descending. The height of the balloon n minutes after it starts to descend is hn meters. Now this question is only made more difficult by the notation, okay? It's the notation that makes this challenging, so try and see past that. hn, the little n just means I could make n5 and that would be the height after 5 minutes. I could make n7 and that would mean the height after 7 minutes. It's just like a way of labelling it, that's all it is, okay? So don't be put off by that. The height of the balloon n plus 1 minutes after it starts to descend is given by this. So this is saying hn plus 1 is k times hn add 20. Now all that means is that to get the height in a minute's time, you need to take the height that it is now, so this is now, and this is the next minute, times it by k, and then add 20. And that's just going to get you the next one, and the next one, and the next one. The balloon starts to descend from a height of 1,200 metres at 9:15. At 9:16, the height of the balloon is 1,040 metres. Work out the height of the balloon at 9:18. Okay, so we know that if at 9:15 it was 1,200 and at 9:16 it was 1,040, they've used this formula. So 1,040 is a minute later. So we've done k times 1,200 add 20. And we know that that must be true. And this is going to enable us to work out what k is. Now, the tricky thing here is that we need to work backwards. If we were doing it, we would multiply by k first. So I need to make sure that I save that bit till last. I'm going to take 20 away from both sides to solve this equation. 1,020 is k times 1,200, and then just divide both sides by 1,200. So 1,020 divided by 1,200 is 0.85. So that tells me that k is 0.85. And we now have our formula. So we now know that to get hn plus 1, the next value, we need to do 0.85 times whatever the height is now, add an extra 20. Okay, that's what our formula is going to be. So at 9:15, let's call that h0. That's the starting height. It was 1,200. At h1, 1 minute later, it was 1,040. h2, well, that would be 9:17. And then h3, that's what we're looking for, because that would be 9:18. So we're just going to keep putting the values in. I'm now going to put 1,040 in here. I'm going to times it by 0.85, and I'm going to add 20. And that gets me 904. To get the next value, I'm going to put 904 in here. So 0.85 times 904, add 20, is 788.4, and that's going to be the height of the balloon at 9:18. Yep, that's it, 788.4 for 4 marks. That topic is iteration, but in context. Sometimes we get it in quadratics, but sometimes we get it with populations or things like that. Question number 21. The graph of the curve with equation y equals f of x is shown on the grid below. On the grid above, sketch the graph with the curve of equation f of minus x. Now, anything inside the brackets changes the direction, the x direction, left and right. Minus is just a reflection. So if I gave you minus f of x, because that's outside the bracket, that would reflect it down here, like that. But because it's f of minus x and that reflection is inside the bracket, it's going to reflect across the y-axis, and that change is going to be from left to right. So we're only changing the we're only changing the x coordinates here. So this is going to go like this, and then down to here, and then up. If you're not happy drawing it freehand, give yourself a couple of key points. So that point would have gone there, that point would have gone there, and then you can kind of have a bit more of a dot-to-dot situation. That would reflect from left to right. And then for part B, the curve C with equation y equals 5 add 2x minus x squared is transformed by a translation to give the curve S such that the point 1,6 on C is mapped to the point 4,6 on S. So this graph, this quadratic, has been moved 3 places to the right. So we would start with f of x. When we move it 3 to the right, we know that that change is happening in the x direction. And so we need to change what's inside the bracket. So inside the bracket is always the opposite of what you'd think. So you'd think if we're moving right, we would be adding 3, but it's actually f of x minus 3. Now, what that means is that everywhere where you see an x in the equation, we need to change it to be x minus 3. We're changing that input. So the new equation is going to be y equals 5, add 2 lots of x minus 3, minus x minus 3 squared. So I've taken everywhere where there was an x, and I've changed that x to be the bracket x minus 3. And that's changing your input. You're changing f of x to be f of x minus 3, and that moves the graph 3 to the right. Hopefully you found that helpful. We were only 33 marks this week, which means we'll be 47 next week, always adding up to 80. So we've got the odd numbers this week, and it will be the even numbers next week for week 16. I hope you found it helpful. Let me know in the comments if you've got any questions at all, and I will be happy to help.